What we're going to do now is we're going to look at solving logs. But before we do that, just a quick reminder of how we solve exponential problems using a common base. If you're looking at letter A, remember what we did was we found a common base. In this case, it is 2. So what we did was we did 2 to the 6, which is 64. The 2's canceled, and we got x is equal to 6. For letter B, we do the same thing. What we have is 3 to the x equals 3 squared, x minus 1. Once again, the bases cancel. Once we have a common base, we have x is equal to 2x minus 2. We subtract the 2x, and that gives us negative x is equal to negative 2. So that means that x is equal to 2. Now, if we're looking at the third one, once again, common base, 2 squared x plus 3 equals 2. Since 32 is in the denominator, in order to bring it up, we make the exponent negative, and that would be 2 to the 5th. Once again, common base, we get 2x plus 6 is equal to negative 5. We subtract the 6. 2x is equal to negative 11. When we divide it by 2, x is equal to negative 11 over 2. So as you can see in each one of these cases, we found the common base and we were able to solve it. Now, what we're going to be doing is we're going to be looking at problems where they don't have a common base. So the first thing that we have to do is we have to isolate the base number. What I mean by the base number is the number underneath the variable. So 3 is our base number in this case. Once we isolate the base number, we're going to use the logarithm to cancel the base numbers. And what we're going to do next is we're going to use change of base formula. We talked about that at the very beginning. And then our last step is to isolate the variable. We're going to get the x by itself. So those are our steps for solving problems that don't have a common base. So if we're looking at these examples right here, first thing that we're going to do is we're going to isolate the variable. Sorry, we're going to isolate the base number. So we subtract the 3, and we get 2x is equal to 6. Then what we want to do is we want to get rid of this 2 right here. So what we're going to do is we're going to get rid of it by doing a log base 2. Now, when we do the log base 2, if you remember from the very beginning of this unit, this right here is equal to 1. Our exponent goes in the front. X times 1 is just x. And we have log base 2 of 6. Also, at the very beginning, we learned about the change of base formula, which states that the log of 6 divided by the log of 2 is the same thing as log base 2 of 6. We put that in our calculator, and what we end up with is 2.58. So let's look at letter B. Once again, first thing that we're going to do is we're going to isolate the base number. Our base number in this case is 2/3. So in order to isolate it, we subtract the 8. So that gives us negative 2/3 raised to the x is equal to negative 7. Now, since we have a negative, we want to get rid of the negative. So what we're going to do is we're going to make it a positive. Now we have the base number by itself. So what we're going to do is we're going to do the log of whatever the base number is. So we're going to do the log base 2/3 of 2/3. And that's equal to the log base 2/3 of 7. Once again, Whenever we have common bases, it always is equal to 1. So the x is by itself. We're going to do the change of base formula. Log of 7 divided by log of 2/3. And that right there gives us an answer when we plug it into the calculator of negative 4.80. Okay, if we're looking at letter C, with letter C, once again, what we're going to do is we're going to isolate the base number. Our base number in this case is the 5 because the 5 is underneath the exponent. First step we're going to do is we're going to add the 6. When we add the 6, what we get is 89. Then what we're going to do is we're going to divide it by 7. 7 does not go into 89, so we just keep it as a fraction. We don't want it as a decimal because we don't want to round something that's rounded. So we're just keeping the exact answer. What we have is 5 to the x plus 3 is equal to 89/7. Now what we need to do is we need to get rid of our base number. How we get rid of our base number is we do the log of the same base. So we do the log of base 5. This right here once again becomes 1. So we have our exponent by itself, and that gives us x plus 3 is equal to, with the change of base formula, it is the log of 89/7 divided by the log of 5. When we plug that into the calculator, we get 2.79. But we're not done yet because this is what x plus 3 equals. It's not what x equals. So our last step is we have to isolate the variables. So we're subtracting the 3. And that right there gives us a final answer of negative 0.21.